Hello everyone. Today we are going to see the question 4 sum, which is the question for today in July Leetcoding challenge. So the question states that we are given an array nums of n integers and we'll have to return an array of all the unique quadruplets. Quadruplets is a set or a vector of 4 terms. Nums A, nums B, nums C and nums D, such that the conditions are the A, B, C and D are the indices of the array. So they are between 0 inclusive and n exclusive. So they are between so they have the values 0 to n minus 1, and the indices A, B, C and D should be distinct. And also, as it is a 4 sum question, from the question itself we understand that nums of A plus nums of B plus nums of C plus nums of D, that should add up to a target sum, and we can return the answer in any order. So these are the two examples. We can see that all the sum of all the example, all the output vectors in the example. So output, as we can see, the output is a vector of vector, and the sum of the vectors terms in the vector of each of the vector here is 0, which is the target sum. So this is 0 and this is 0. So I'm going to discuss an approach to this question which I used to solve this question. First, what we will do is, so these are the constraints. So from this we can get that we can use a n cube type of approach for this. So my approach was, first we'll sort the array. Because I'm going to use the 2-pointer technique to solve this question. We can also use a brute force method, but it may result in time limit exceeded. I have not tried it yet. You can try at your end. In the brute force method, we can use 4 loops, and then we can iterate through all the array, and then we can find we are taking all the quadruplets which can be possible, and then we are taking the sum, and if it is equal to the target, then and it is not a duplicate value in our vector, then we will add it in our result. But the second approach can be, it will also be a kind of naive approach, but it can be that we can take the vector and we can iterate for 3 times. I is equal to 0 to n minus 1, j is equal to 0, I plus 1 to n minus 1, and k is equal to j plus 1 to n minus 1. And for the 4th term or the 4th index, we can find that the number which is corresponding to that index, the number we can find using binary search. So the time complexity of this solution will be O of n cube log n. But in this solution, I'm going to discuss a solution in which we can find this in O of n cube. The time complexity of my solution will be big O of n cube. If you have any better solution, you can also share them in the comments so that everyone can get to know and learn. So my approach for this question was simple. First, we will sort the array. Then second, we will take 2 pointers I and j, and we will traverse the array. I will be going from 0 to n minus 1, and j will be going from I plus 1 to n minus 1. And in both the loops, and then we will take a new target sum, which will, let's say, call it as target 2. That will be equal to original sum, which is the target, minus nums of I minus nums of j, and we are going to apply the 2-pointer technique to find a pair of 2 distinct indices which will give us a sum equal to the target 2. And for this, we'll have to be careful that to avoid duplicates, we'll have to skip over the duplicates in this question. So let's start. So if you have got the logic, you can try and test out your code. And let's start with the coding part. So first, we are going to handle a base case. So let's say, so first we'll declare a result, vector of vector int of result, and then we'll handle a base case. let n is equal to the size of nums array, nums dot size. And if n is less than 4, that we have less than 4 terms in our nums array, then anyway we cannot have an answer, so we'll return an empty array. And then now let's start with the original approach. First we'll have to sort the array. And here I'm going to use the sort function directly, nums dot begin comma nums dot end. In the second step, we are going to apply our two pointer approach. For first, we'll take two loops to traverse all what we can say. We'll traverse the array for int I is equal to 0, I is less than n, I plus plus. For int j is equal to I plus 1, j is less than n, and j plus plus. Then we'll make a target to variable, which will be our new target to sum, and the target to sum will be target minus nums of I minus nums of j. And then we'll use the two pointer technique to find two indices which will have a sum equal to target 2 in our given array. So let's start with the two pointer technique. So for this I'm going to take two pointers which are, let's say, left and right pointers. So let left pointer will be equal to j plus 1, which is basically the next index after j, and the right pointer will be equal to the last index of the array. And we will we'll loop till left is less than right. Here we'll take some variable, let's say cur sum, which is the current sum, and that will be equal to nums of left plus nums of right. Then we will see if cur sum is less than our target 2. If the target 2 is greater, then we will also have to increase the left, right, so that we take the higher terms. So we will increase the left. Else, if the cur sum is greater than target, then we'll have to reduce some elements. So we will reduce right minus minus. So we'll do right minus minus. Else, if the current sum here, if the current sum becomes equal to, so here I have done a mistake. It should be target 2. So if the current sum becomes equal to the target 2, then we have got our quadruplets. Then we will make a vector of int which will be quadrup, let's say, and this will be of 4 terms because we have a quadruplet. And then we can directly initialize it with our terms. The terms of the vector will be nums of I, nums of j, and the third and fourth terms will be nums of left and nums of right. So here, and we'll push this in our res, which is the result, which is the res dot pushback quadrup. So now we'll have to go over the duplicates, or we'll have to skip the duplicates. So how can we do that? While left is less than right, and if nums of left plus plus or left plus 1 is equal to, we can say it is quadrup of 2 because it is 0, 1 and 2. Then we will have to increase our left. So basically here I am increasing the left till all the similar or the duplicate elements are skipped, or we reach the end of the array. Till that time I am going to continue this skipping, and this will also have to repeat for right. If there are any duplicates, here we'll have to change the condition that if right plus 1 is equal to nums quadruple of if it is equal to quadruple of 3, then we'll have to do right minus minus, and then if so, here we are skipping all over the duplicates, and after this loop is over, we are in the J loop, right? So after the J loop becomes over, after this rather two pointer loop becomes over, then we'll also have to skip if there are any duplicates after this, after j index itself, then we'll also have to skip those duplicates. So if the j plus 1 is less than n, this is the base condition, there are no duplicates, and nums of j plus 1 is equal to nums of j, then what we'll do is we can do j plus plus. Here also we can repeat the same. Here instead of j we'll write I, and nums of I plus 1 is equal to I. Basically we are skipping all the duplicate elements, and then we'll do I plus plus, and then at the end of this loop, this for I loop, two loops will return our result. Let's run our code and test it. Okay, it's giving TLE. Let's debug it. So here let's debug our code because it's giving us a TLE, left and right. We can simply do left and right because anyway we'll have to increase the left and right for once. Otherwise we may get duplicate answers. And yeah. Yes. Yes, so now it's giving us the correct answer. So let's submit our code. So yes, now we can see it is accepted. And so yes, this was the solution. If you have any doubts, then you can comment below. And thanks for watching. Thank you.